In this video, we'll work through a few exam and test type questions for the quadratic function. So here we are given fx equals to negative 2x squared plus 18. And our first question is, write down the coordinates of the y-intercept. So to find the coordinates of the y-intercept, I need to make x equal to 0 in the given equation. So I'll have y is equal to negative 2 times 0 squared plus 18. And therefore y would be equal to 18. So the coordinates of the y-intercept is where x is 0 and y is 18. In our second equation, the question is, determine the coordinates of the x-intercepts. So for the x-intercepts, we will make y equal to 0. So remember that y and fx are referring to the same thing. So I'll replace fx with a 0. So I'll have 0 is equal to negative 2x squared plus 18. Now I can divide everywhere by a negative 2. So if I divide 0 by negative 2, I will have 0 equals to, and then negative 2x squared divided by negative 2, the negative 2's will cancel out. So I'll have x squared, and then lastly, plus 18 divided by negative 2 would become negative 9. Now I have a difference of 2 squares. And I can easily factorize this expression. So it is 0 equal to x minus 3, x plus 3. Therefore, the x values of the x-intercepts are 3 and x equal to negative 3. But remember, the question asked for coordinates. So we have the x values and we also have the y value of 0 for both intercepts. So the x-intercepts will be at negative 3 and 0 and 3 and 0. In our third question, we have sketch the graph. So we already have the y-intercept of plus 18 and two x-intercepts of negative 3 and 3. So what I can do is plot the y-intercept and the two x-intercepts on the x-axis and then connect those 3 points with a curve. Remember, when we draw, we end the graph with arrows, and we also name the graph by putting the equation next to it. So the next few questions we can answer directly from the graph which we have sketched. First, we will determine the turning point. So the turning point is where the graph changes direction, and it is at the y-intercept. So the turning point of this graph is where x is 0 and the y-intercept is at 18. The next question is determine the maximum value of the graph. So here we can see the graph reaches a maximum value at the turning point where y is equals to 18. So the maximum value is 18. Our next question is to find the domain and range. And in a previous video, I discussed at length how to find the domain and range for a quadratic function. But in short, the domain represents the x values, and the x values are all the real values of x. And we can see that y is smaller or equal to 18 everywhere on the graph. And as I mentioned, go look at that video where I explained this more fully. Our next question is to find the axis of symmetry. And I also explained this before, but the axis of symmetry is the axis where if I fold the right hand side over the y-axis, it will fit exactly on the left hand side. But the equation of the axis of symmetry is not the y-axis. We rather say it is where x is equal to 0. Because everywhere on the y-axis, all the x values would be equal to 0. The next question is a new one. Find the values of x where the function increases. So what you do when you read a graph is you start on the left. And if you follow the graph and you're moving upwards, then the values are increasing. And we can see that these values are increasing up until the turning point where the graph is neither increasing nor decreasing. So for all the values of x on the left of 0 or smaller or equal to 0, the graph would be increasing. So that is for x smaller or equal to 0. And if I follow the graph from the turning point towards the right, I can see that I'm moving lower and lower down. So for these values of x, the graph is decreasing. So it's decreasing towards the right of 0, or where x is bigger or equal to 0.